Hello and welcome. My name is James from the DSO Imager channel, and tonight I'm going to show you my processing on the Western Veil Nebula. Now, it's certainly the season of Cygnus because you're seeing, at least I'm seeing, on all my astrophotography related social media, pictures, wonderful pictures of the Cygnus Loop and of NGC 7000, Crescent, and Tulip. It's a lot of people are shooting these targets. The Veil Nebula, eastern and western, and the Cygnus Loop as a whole, is an excellent target because it is bright. It's, in my opinion, relatively easy to process, and it's an awesome target, especially for people who are cutting their teeth on astrophotography. So with this video, I'm wanting to do two things. I'm like most of my other workflow videos, I'm just sharing the image that I took and showing how I processed it. So my more experienced viewers maybe can pick up little tips here or there. And if you're new and you're tackling this target for the first time, maybe this will help you process it, especially with getting those colors down. Now for this particular target, I chose to do the HOO color palette, so I got hydrogen and O3, and I'm using Astrodon 5 nanometer filters. The telescope is the Astronomics AT115 EDT. It's a triplet 115 millimeter refractor. I am using the 0.8 reducer, so that gets me down to a focal length of like 644 millimeter. And for the camera, I'm using the ASI 1600 mono. Okay, I got a total of about 10.5 hours, pretty even between HA. No, actually, I take that back. I think I got a little bit more HA than O3. But anyway, here is the HA, and here's the O3. All right, so this is stacked. No processing done on this at all. And I mean, you can see why this is such a cool target. All right, and so first things first, I did a crop just to trim the stacking artifacts, and then I ran dynamic background extraction. And we can actually see what I did here. So basically I put a reference point mostly in each corner. I put a reference point here because obviously this corner is populated, and I found a clean spot in the center. And those worked out pretty good. What I ended up with was this here. So that's with dynamic background extraction. And then after dynamic background extraction, I run deconvolution, and this is the HA with deconvolution. Now, it may not look too different, but when you zoom in, that's where it becomes more noticeable. So let's do a comparison here. Yeah, so you can see how we got more detail showing up here. I don't know how well this is showing up on YouTube, but I mean this kind of looks a little blurry compared to this. It's not a huge difference, but it makes a difference. Alright, and so I did the same thing to O3. And then I combined them in the LRGB combination tool. Oh, actually, before I did that, I want to show one other thing that I did. I did what's called a linear fit. And so what this does is it gets both, in this case, both the HA and the O3 to the same level, so that this actually helps a lot with like color correction and stuff. So one channel doesn't overpower another channel if it happens to have more signal. Now, there are different strategies involved in what you can use as your reference image. Generally, you want to go with the image that has the most signal, and an easy way that you can determine this is you go to histogram transformation, and you literally look at the histogram of each of the frames. So you can zoom in on this, right? You can barely see this. Pull back on the mouse wheel, and it's like zooming in, right? And so I'll zoom in like this, all right? And so that's the HA, and now I can go down to the O3 and see the difference. The HA definitely has more signal than the O3. So I use the HA as a linear fit, and all you do is just drag this and drop it on that. That's it. Oops. And so after I did that, I used the LRGB combination tool, and there you can see HA, O3, and O3. And that's why we call it HOO. Alrighty, and that's what I got there. Okay, and so, I mean, I thought there was a lot of potential here. I mean, this is about half the integration time I typically get. But honestly, if you look at these stars, they're not the greatest. The weather we've had here lately has been very windy, and so I didn't want to infect a current project that I was working on with what I knew were going to be bad stars, but I still wanted the image, and so I thought this would be a good detour while I wait for better nights. Also, we're just on the tail end of a moon cycle. The moon is waning, and most of the HA in this picture was actually captured with about an 80% or greater moon. I think the night of the full moon I didn't image, but both nights on either side of the full moon I did image. Alright, so let's step through everything, and actually we can go with this here, right? So I made a clone, and the first thing I did was stretch it, and I stretched using the Easy Processing Suite, soft stretch. Okay, so this is after the stretch. Next I remove the stars, and that's without the stars. And just real quick, there's our stars. Alright, so I used Star Exterminator to pull these out. Real quick with Star Exterminator, there was an update to Star Exterminator, and it was a really good update. So, a new feature here, this unscreened star. So if I hover over it, I'll just leave this up here for a moment so you can read through this. But this process did a really great job of creating the stars and then putting it back. So prior to this, I was having issues where, especially on some larger stars, they have kind of this faded, translucent look, and they just didn't look the greatest being added back in. And how I was adding the stars was just going into pixel math and doing starless plus stars. You can see down there near the bottom that there's a new formula for putting the stars in there, and I've been using that formula on a couple of images since this update, and it works great. Like this may have, between this and my latest tweaks to how I work stars, may have resolved any of the issues I was having with stars. So anyway, we'll get back to the stars. I just wanted to do a call out on that Star Exterminator update. Alright, so let's go back to our starless version. I mean, this I think looks pretty good already, to be honest. What I did want to do was try to pull out some of this fainter stuff over here to get some separation. And of course, you got, with HOO images, you always have this kind of O3 background noise that we have to deal with as well. So now you can see I've already got a mask on there. And I'm going to show you this mask here. So this might be handy for some people. So I'm going to back through this mask. There. So what I did was I extracted the luminance off of this, because what I'm wanting to do specifically is take care of this background color and try to enhance these fainter areas. And so doing a range mask or something like that alone is not going to be precise enough, and you'll end up losing some of this. So you extract the luminance, and I'll do it again here. Let me take this mask off. You just extract the luminance just like this. And then we're going to use this as our mask. So that's what we have here. Now I have a preview box here because as I'm making little tweaks, I'm kind of looking at these fainter areas. But this is what I did to prepare the mask. So you can see I'm darkening the background, trying to pull as much out here. And it's kind of cool how you can see some of this stuff down here starting to reveal itself. And you can use histogram and curves, and you know how usually with the histogram you want to avoid clipping, right? Well, when working on a mask you want to clip, because the darker this background is, the better the mask is going to protect. And in fact, you'll see that I didn't quite get this dark enough. But it was good enough. So yeah, keep making adjustments. Very subtle steps with the curves, and there. So here I just use noise exterminator because I want to smooth this out. I didn't want to propagate this grain while working with curves and saturation, and so I used the max settings on noise exterminator, and that did a pretty nice job. And so that's what I ended up using for this mask here. And now you can see I'm making the adjustments on here. Let's zoom in so you can see the difference there. See how there's more green in there? And that's where I ended up with after using that particular mask. And then it was just more curves work, the same old stuff. I did use unsharp mask. Let's see. Yeah, so this is a range mask, and I use the unsharp mask only on these areas that are unprotected. So before unsharp mask and after sharp mask. So I like to go subtle with the with unsharp mask. It's very easy to overdo it. In fact, I mean, zoomed in here, it feels maybe it's a little bit overcooked, but this is what I went with. Now, I want to mention one thing about the masks. Let me go back. Oops. So the thing is, you see a lot of images out there where the O3 is very blue, and that's fine. I mean, that's it's all in the eye of the beholder. You're certainly free to process your images how you like, and color is a very subjective thing. And I can certainly appreciate the red and the blue, but I see a lot of images out there with like purple. And I just wanted to show here that usually the way you get rid of make this bluer is by subtracting green. And if you pull back on curves, pull back on the green, you're also introducing a lot of purple. And so I'm speculating that a lot of these images out there where you have a lot of purple is where they pulled too much green out. And so that's where a mask could really help. I mean, if you want to isolate just the blue, or the red, you can make a color mask. Right, so this is a color mask that I use for red, and I created a range mask off of this color mask, so that while I was playing with the color of the blue, the O3, I wasn't impacting the messing with the red too much. Now I am going to do a plug for one of my videos on my YouTube channel. So if you're not a subscriber, go ahead and subscribe and check out the videos I have. I did a video specifically on managing color, and this is an example of how that applies and how adjusting green can impact the colors in your image. Alright, and let's look at the stars. Alright, so the reason you see a preview box here is that when I do things to the stars, I like to first look at the preview in here. So it kind of, this would be like my playground before making any kind of actual changes. But anyway, so we removed the green. Oh, actually first I did morphological transformation. So that's what you're seeing here. Then we remove this here is removing the green, so you can see there's kind of like that O3 tinge on all these stars. So subtracting green, then we're inverting, subtracting green again. This takes care of any kind of magenta or purple that resulted from subtracting the green. And I pull back on curves a little bit and boosted saturation. And that was pretty much it. And what I'm looking for is a nice distribution of blue and orange stars, basically. And then I used that formula that was highlighted in the star exterminator. And I can show you the formula again. It should still be in pixel math. Yep, there it is. So we took that clone and the clone stars, and the result was this here. Let's get rid of that preview. So yeah, in regards to the stars, quite happy with how that came out. I think it did a pretty nice job. I was also happy that I didn't get any kind of halo here. I thought that this star here for sure was going to give me that that ASI 1600 micro lens diffraction pattern there, but it looks okay. And so as my last step, as usual with a lot of these images, I will take them into Photoshop and tweak them just a little bit. And let me bring over that version here. I also decided to rotate and flip. I thought that this orientation I liked the most. And so that's pretty much it. It was relatively straightforward. Processing on this wasn't too bad. I find HOO images pretty easy to process. If you're using a one-shot color camera, you know, one of these dual narrowband filters like the L Extreme is perfect for a target like this. Even color. This is such a bright target that these HOO colors are not far from what you see with the regular broadband color. And I mean, you can do SHO on this target too. SHO I think is more of a challenge to get it to look good. You have a lot of very colorful images out there with a lot of green in them, which of course I like. But there's a couple out there that did a really nice job of balancing green and giving you some of this gold and yet maintaining blue in there. But anyway, I went with the classic HOO, and it was just a short short job with some less than ideal conditions, and overall I'm pretty happy with the results. So with that, I'd love to hear any comments that anyone has, questions. How do you guys handle your Western Veil pictures or Cygnus Loop pictures? And of course, give this video a like if you found it entertaining or useful. And clear skies.